Welcome! There are many different criteria to use when determining which gear is best to use in different driving situations. In this lecture we will start by looking only at one criteria, and that is which gear leads to the lowest fuel consumption. If we want to find out how fuel efficient different powertrains can be, we need a method to decide which gear leads to the lowest fuel consumption. This method can then be used in the simulation to control which gear is used during different parts of the driving cycle. The method can also be implemented in the control software for an automatic gearbox. Assume that the vehicle requires 1100 Newton of traction force at 65 km per hour, which equals 20 kilowatt traction power. We can see from this diagram that it is possible to use all 5 gears in this operating point. That means that we have 5 different operating points for the engine to select from. How can we determine which of them is the best? By plotting the specific fuel consumption values in the diagram, we can determine which gear is the most fuel efficient. Specific fuel consumption means how many grams of fuel is used per kilowatt hour of mechanical work the engine produces. Since all the 5 operating points produce the same 20 kilowatt of power, the one with the least fuel consumed per kilowatt hour will be the one leading to the lowest fuel consumption. By reading the specific fuel consumption contour and interpolating, we see that the gear leads to the following specific fuel consumption. Gear 1 almost 600 grams per kilowatt hour, Gear 2 about 350 grams per kilowatt hour, Gear 3 300 grams, Gear 4 280 gram, and Gear 5 300 gram. In this driving situation, Gear 4 leads to the lowest fuel consumption, which is 280 grams per kilowatt hour. If we could select gear ratios freely, not being restricted to the 5 gear ratios of this particular gearbox, we could get a little lower fuel consumption than what the 4th gear leads to. We can find this optimal engine operating point by looking at all the points along the 20 kilowatt line and find which leads to the lowest specific fuel consumption. This is that operating point, and it leads to 278 grams of fuel consumed per kilowatt hour. Now we assume that the vehicle drives in 120 km per hour and need 1800 Newton traction force. If we analyze this from the engine perspective, we get these engine operating points. This time we can only select from 2 gears. Gear 3 leads to about 295 grams per kilowatt hour and Gear 4 about 290 grams. Again, Gear 4 leads to the lowest fuel consumption. The overall lowest possible fuel consumption at 60 kilowatt engine power is about 288 grams per kilowatt hour, and it is in this operating point. The method we have used to find the most fuel efficient gear can be summarized in these 3 steps. For the used force speed operating point of the vehicle, first calculate the operating points for the engine on different gears. Secondly, plot the engine operating points in the fuel consumption map. And finally, select the gear with the lowest specific fuel consumption. So, now we know how to find the most fuel efficient gear, but to better understand which engine operating points are desirable, we will now determine which operating points give the lowest fuel consumption at different values of engine power. Here we have plotted constant power lines for different engine power levels. If the traction power is 5 kilowatt, we can find the lowest specific fuel consumption, 350 grams per kilowatt hour, at the minimum engine speed, 900 RPM. If we do the same at 10 kilowatt, we get this operating point, which is at a fuel consumption of 295 grams. At 20 kilowatt, the minimum consumption is 278 grams at 1400 RPM. At 40 kilowatt, the lowest fuel consumption is at 2400 RPM. This is also the most efficient operating point of all in the whole operating range, only 260 grams per kilowatt hour. Up to this power, the specific fuel consumption at the optimal operating point has been decreasing from 350 grams at 5 kilowatt to 260 grams at 40 kilowatt. As the power increase above 40 kilowatt, the best possible fuel consumption will increase a little. At 60 kilowatt, it is 288 grams. At 80 kilowatt, 320 grams. At the peak power of the engine, there is only one operating point to select from, and there the fuel consumption is about 350 grams per kilowatt hour. If there is no engine power, 0 kilowatt, the lowest speed is the most efficient operating point. We can see a trend for what is the ideal operating point as the required engine power varies. At low power, the minimum speed is the most fuel-efficient choice, and when the power is higher than about 15 kilowatt for this engine, the most fuel-efficient operating point is at a high shaft torque, a little lower than the peak torque of the engine. The optimum operating point at higher powers are not exactly the same engine torque, but they vary a little up and down depending on details in the fuel consumption map of the engine. These variations are different for different engine designs, but they all have the same general trends, and that is that the peak efficiency is at a high torque, which often increases a little with the engine power. The operating point at the engine's peak power is always at the maximum torque of the engine in a high speed, as that is the only operating point at which that power can be delivered. Since a normal gearbox only has a limited number of gears to select from, the optimal operating point will most of the time deviate from this ideal operating curve. However, the operating points will be selected so that they are close to this optimal line whenever that is possible. A simplified but still very fuel-efficient gear selection strategy is to always select the gear which gives the highest engine torque. Due to the limited number of gear ratios to select from, this simplified method will most of the time lead to the same gear being selected as for the detailed method presented earlier in this lecture. In this lecture you have learned a method to determine which is the most fuel-efficient gear to select in different driving situations. The method goes: first calculate the operating points for the engine for all gears, then plot them in the fuel consumption map. Finally, select the gear with the lowest specific fuel consumption. You have also learned a simplified strategy to select the gear which leads to the highest engine torque. This is equivalent to selecting the gear which leads to the lowest engine speed. Now you know how to determine which is the most fuel-efficient gear in different driving situations. Practice to do that in the following exercises. Thank you for your time.